Today we're going to build a small, silly tool which will teach us how to manipulate output in your terminal. Specifically, we're going to learn how to colorize our output and even animate it a bit. As an inspiration, we're going to be looking at lolcat utility, which does a lot of things, and by the end of this video we should be able to achieve something like this. First of all, whenever we output some text and run it through lolcat, we get all the lines in some rainbowish color, and if we run it with an animation flag, it animates every single line, and hopefully by the end of this video we will be able to replicate these effects. So, main goal of today's project is to learn about ANSI escape codes. I have found this particular article to be quite good as an introduction into the topic. I suggest that you look through it before continuing, but if you don't want to or can't, just know that whenever your terminal deals with some output and it stumbles upon this character or this escape code, it will try to execute commands following it. In this article, there are quite a few commands presented here, and it says that you can manipulate your cursor, you can manipulate your scrolling, save and restore cursor position, and set some graphics mode. And we will be interested specifically in this graphics rendition command, which allows us to set background color, text color, make your text italic, underline, bold, and so on. Now, as this project is quite small, I decided to use Zig programming language, which I haven't used before, but I was really interested in trying it out. Now, before recording this video, I went through the documentation and tried a few smaller projects just to make sure that I have enough knowledge of the language so that I don't constantly Google for Zig related stuff. Now that it's clear what our project goals are, I guess we can get started. And as usual, first things first, we need to create our repository. Let's do it right away. Let's call our project sillycat. Let's use zig git ignore, create the repository, and once it's there, we can clone our repo, go inside it. It's pretty much empty right now. We can move our placeholder text here, which looks like this, and we can init our project using zig init command. Now zig init initializes your project for binary, so executable, and for library modes, all together. And as we're writing a simple CLI tool, we won't need the library part, so we can remove it right away. We need to also adjust the build, because we are removing this root zig and we don't need that. We need to adjust everything in this build file. So all the references to the library part we need to drop. And once it's done, we can then jump to main and pretty much clean it up as well. We don't need any tests, any main implementation, and I will move the import of standard library to the top. Now there is one thing with Zig, is that I use ZLS language server, and somehow its default configuration doesn't work well for me, and I have to apply a few adjustments so that it works really well. So there is this JSON, zlet.json, which you can put into your project root. right? We can ignore the path, but pretty much this command, enable build on save, makes my language editor work correctly in the sense that after each change, after each file save, it will provide correct diagnostics to me. And once this is done, let's see our main Zig, we can print out simple hello world. Let's do it this way. So stdout is get the writer is stdout writer. Now we can finally print something like hello world, and we need to try it because print says that hey, it can fail. Now we can run our command and it runs successfully. Now, because I don't want to type it out every single time zig run src main zig, I would like to create an alias as I did in my previous projects. We can do zr for zig run src main zig, and once this alias is up and running, we can simply use zr and it will do the same thing as before without the need to type everything out. All right, that's pretty much great. Now first, before jumping into the dealing with standard input, let's try to use this placeholder text inside our code. So let's say we have some text, and this is like how multi-line text works in Zig. And once it's there, we can say, hey, let's print it out. Print out a string given text. And then we run our program and it prints out everything correctly. Now let's jump into the ANSI escape codes, which tells us that whenever we see this specific character, so let's do and add it to our output x1b. There are different control sequences, right? So control sequence starts with a square bracket, and there is a function m that we're interested in, which deals with graphic mode. So we will have to use m, and it takes some parameters which are described in this table, and the parameters come before m, and we will start with using a simplified text coloring function, which simply tells you or asks you to provide a color number. It deals only with 8 colors. So there is a number starting from 30 up to 37. Let's see, let's start with 30. And we can also, at the end of output, would like to reset and turn everything off, which means that we can say, hey, x1b 0m. So running the same command, but with an argument 0, which resets everything. Let's see what it does. And our text became darker, much darker. Let's see what happens if we use 31. It's now red. 32 is green. Pretty much as far as I understand, there is this color palette provided on some wiki, and we're dealing with these 8 colors. So 30 is like a 0, which was like black, and dark red, dark green. Let's see if we can output some bluish color, dark blue. Seems to be working just fine. Now this function is pretty dummy in a sense that it allows you only to set 8 different colors. There's a bit more complex function that allows you to pick any color from this whole palette. Let's try to use that in our code. So it says we need to pass some parameters like this, and there is an integer n, which is from 0 to 255, which pretty much describes which of these predefined colors from this palette you would like to use. So let's try to colorize every single character of our text. To achieve that, let's iterate over our text for each character. We will try to print it out, but we don't need new line, and we need some sort of the value of the color that we want. So we need to keep track. We need to keep track of how many characters we're printing out and update it every single time. And instead of printing out string, we need to print out our char. Let's see, too few arguments because it still needs a first parameter here. So index goes here and char goes into this block. Running it, we see that we achieved an interesting effect where each character now receives a predefined color from this palette. And what's the most interesting part for us is the next function, 38.2, which allows you to set any color, any 24-bit color using RGB values. Let's try to update our code to use it. So instead of 38.5, we need to use 38.2, and then we need to provide 3 colors. Right now we don't have them, so I'll just set index, index, index. So this is like red, this is green, this is blue, and you can probably guess what the effect is going to be, because all the time red and green and blue are the same. We'll probably just see all kind of shades of gray. And that is exactly what happens. So here comes the interesting part. We would like to have different red, green, and blue here, and so that they don't always end up the same. And we would like to achieve this rainbowy effect that we showed you in the beginning. And I need to go to some Graphtoy tool to explain how this effect is going to be achieved. Now this tool just is very simple, very interesting one. It shows you what the graph looks like, and we're going to be using the sinus function, which is provides you an endless output from -1 to 1. So the values of sinus x always end up in an interval from -1 to 1. What can we do with this function? We can pretty much increase the interval in a sense that currently it's from -1 to 1, and if we want to make it from -2 to 2, we simply multiply it by 2, right? So the top is now 2, the bottom is -2. You can see the values in the bottom left corner. If we multiply it by 3, then it goes up to 3. Here is a 5, we can multiply it by 5. Then we can also shift it to the left and to the right by pretty much saying, okay, I want you to shift by 1. Or actually, like, this doesn't shift it to the left, to the right. It adding some value afterwards pretty much changes the interval by applying 1 to all the values. So if it was from -1 to 1 before, it is now from 0 to 2. If we make it like +5, then it goes from 4 up to 6. Now I was talking about shifting it, and shifting needs to be done here. So sinus works with radians, and we know that circle is 2 pi. So pretty much if I add 2 times pi here, nothing changes, right? So the graph remains the same. But for example, if I divide it by 3, our graph just moved by 1/3 of 2 pi's. If we do 2/3, right, of a circle, then it moves even more than before. And this whole information is needed to define our red, green, and blue values using the sinus function. So let's start with sinus x and 3 values. So one of them will be red, one of them green, and the other one is blue. Right now, all 3 of them produce the same values, and as we saw in our output, it pretty much produces all the shades of gray. So we would like to first shift green and blue values. This one gets shifted by 1/3 of a like circle, which is 2 times pi divided by 3. So this yellow moved out a bit. And this one is 4 times pi divided by 3. As you can see, every single color is now peaking at its own time, and this should provide a very interesting effect in the end. But before we can proceed putting it into code, we need to adjust our graphs, because right now they produce values in the range from -1 to 1. And the trick here is to first multiply it by 127, so that interval becomes from -127 up to 127, and then we can shift it by adding 128. And interestingly enough, the values become from 1 up to 255, which is exactly what we need to provide to our RGB values. The only thing you see here is that the value changes too rapidly, and we can manipulate that by reducing x as much as we want to. And one of the values I have found to be good for this cause is just dividing x by 10. Which makes our graph to take longer for it to peak at the top, to peak at the bottom. So these 3 things is how our red, green, and blue are going to be calculated, and why they work, why they produce like different values for the same x. So let's try to put it into code now. Let's create a function, something like get rainbow color. Let's see what it does. It will produce some sort of color structure. Let's define color as a struct where we have red, green, and blue. Now we can as we are going to be iterating over text characters, we will probably receive index or like position of the character. Let's say position of the character, and based on that position we will return its color. So let's start with red. Red is going to be sinus times 127 plus 128. And here we have position divided by 10. This is red. Next is going to be green, which is same thing, but we need to adjust its position. So shift it to the right a bit by adding 2 times stdin math pi divided by 3. I think I need to add all those numbers to make the compiler happy that we're dealing with floats and not integers. And then we can do the same for blue, except that we shift it by 2/3 of a circle. Now, when we have these values, we can produce a color structure to return. So we're gonna return something like R is red, G is green, and B is blue. Yeah, we need to put a dot here. All right. If we try to compile it, it runs as before, which is nice. So for each character, instead of using the index or position of the character in the text, we're going to be using color red, color green, and color blue. Where does this color come from? We're going to say, hey, get rainbow color given our position, index. And now that we're using this function, our compiler starts to notice errors. It says incompatible types because we have floats and position is simply an integer, unsigned one. And the easiest fix is probably just to say that, hey, my position is going to be float. And this is the only place where we need to change its type. So we're going to say float from int. And now another error, it says, hey, you have calculated some float value, but I expect some byte, unsigned byte here. And we showed on the Graphtoy that these values, red, green, and blue, are guaranteed to be within an interval of values like 1 to 255. So it is safe to simply cast int from float, knowing that, hey, these values are gonna fit into what we expect it to fit into single unsigned byte. All right, looks like no errors. Moment of truth. Let's see what happens. And we get very interesting, nice looking text. But the thing is that if we use lolcat, we see that it doesn't jump from color to color, but it slowly fades from one color to another. And we're not like fading, we're pretty much using next color for each next character. Let's try and achieve the same result. How can we do that? I guess we need to somehow adjust position, saying that, hey, instead of using new RGB values for each position, we're gonna adjust this position so that the same color applies to different positions. Let me show what I mean. Let's say some P is going to be like position divided by 3. We can use P everywhere here, which means that single color is going to be produced for 3 different positions. Let's have a look what changes on our side. It looks a bit better in a sense that you can see that now we have like 3 characters with the same color, so it takes time to fade in from one color to another. It is not the same as in lolcat, but we do not like try to copy it, we simply try to achieve the same effect. As I understand, we can simply say that, hey, instead of 3 colors instead of 3 characters, use 6 of them. And now we can see that, hey, the fading is much slower than before. But I will remain at 3 characters per color. Now, one thing that you noticed is that our CLI tool is using built-in text or hard-coded text. So it's time for us to change it and use stdin for our text manipulation. Right, so we need to somehow get this text from stdin. So let's define stdin as stdin get stdin. So there is a reader which we will use to read things, Now, we will need to work with lines. So how do we read lines from stdin? Pretty much, I think we can use something like stream until delimiter. What it does is, it says writer, so we need to put data somewhere. We will have a buffer which will use like 1 kilobyte of memory and defined in the beginning. Then stdio fixed buffer stream, which will use our buff to store data. And our writer is going to be fps writer. Delimiter is simply new line, and the size, we cannot read more than the buffer that we have, so we need to tell that, hey, we're limited by buffer length. Right, I think, yeah, it throws an error, so we need to try it. And once we execute it, we can say that, hey, my text is fps get written. So whatever I have written into this buffer. Right, it says that, yeah, I need this to be mutable. Right, let's see how that works. I don't think it will work right away. All right, we broke something in our code. What did we break? Yeah, the error code isn't really helpful here. The constant pointer. All right, I think, yeah, we need to make buffer mutable as well. Now it compiled, but it doesn't do anything. Well, and it doesn't do anything because our alias, if you remember, is simply running main Zig. So we want to change that. We will redo our alias saying, please first cut our text and then run Zig, run src main.zig. And if we do that, yay, we see that we have read a line from standard input, applied the colors, printed it out, but then we stopped. And we stopped because, well, we read until delimiter only once. How do we read all the input? Well, should be easy, saying, all right, some endless loop. Let's try to read that. And yeah, this whole thing moves inside. And if we run it, it produces. Right, first thing that we notice is that produces the same text, so same lines. It means that we need to, after reading each line, our buffer stream needs to be cleaned up. So fps reset is needed. And secondly, you notice that, hey, there are no new lines. So when we read the line here, we do not produce a new line in this buffer output. So we can say that, hey, once we're done, let's output new line as well. Let's see how that works. Yeah, incorrect. This is actually character, right? So we're not producing this line here. We printed character by character. So we should simply say that, hey, writer print new line. Once we have printed all the characters of the line, we simply produce a new line ourselves. Running it again, we can see that, hey, it's kind of working. So we see that our lines get colorized the way we want, but in the end we have, hey, end of stream error. And the thing is that there are deprecated methods which say read until delimiter or end of file. And it shows you how to handle end of stream here. So whenever an end of stream is reached, we are pretty much saying that, hey, everything's fine, I'm happy with that. We do not need to throw an error. So let's reuse the same logic on our side as well. First of all, need to drop the try, then we need to catch an error, switch on it, and once we reached everything, I think we need to not return, but we need to break from the while. So we need to say break. Alright, it doesn't like something, it needs semicolon. Alright, so whenever it tries to read standard input and reaches end of stream, and it sees that we haven't read anything from standard input, then it simply breaks out from while loop. Let's see how that works. And the whole file is being printed out. Now you notice that the coloring of each line is absolutely the same. And if we do the lolcat run, you can see that it kind of shifts to the left with each line, and we would like to achieve the same result. So this dimming here happens somewhere here, then somewhere here, somewhere here, here. So it's moving. How do we do that? We pretty much need to keep track of number of lines that we have outputted, where we are. Let's do that. Let's count the lines. And we can pass the line or use that. Yeah, we can probably pass number of lines to get rainbow color. And we will call it probably not the lines, but something like offset. Our position is going to be pretty much defined by this offset, and we need to cast it to float from int. It must know some result type, so let's do it a bit easier, like f64, and again cast it right here, float from int. Now this offset is pretty much number of lines that we read so far. If we run our tool again, you can see that we have a slight shift to the left, so it's a bit better than before. And then we can manipulate the offset, let's say by also multiplying by some constant. And the effect is now much more clear. Right, the shift happens, and this is pretty much exactly what we want, which is really nice. Now, next thing is that we want to replicate is how the animation is done. So, as I showed you in the beginning, if we run the lolcat with animation flag, it prints out the text line by line, doing some sort of animation along the way. We would like to try and reproduce the same thing on our end as well. Now we won't go into reading the program arguments and simply do it with some sort of switch, for example const animate, which is like boolean true. In here we will say that, hey, we have read a line, and if animate, we do something, and else we simply What do we copy? Like we do something else, in a sense that we simply output the text like this. Let's put animate to false, and everything should continue to work as before, and it does. But if we put animate to true, pretty much don't get anything useful. Yeah, just new lines. So we need to start thinking how do we animate this thing. Let's see. We need to do, let's say we need some frames, like some sort of how many animation frames we want. Let's say, I don't know, 20 or something. Next, we need to define some counter, like current frame 0, and let's do like while frame is less than frames. I think we can do it like frame plus 1. Maybe I'm mistaken here. I think it's done like this. All right. So for each frame, we are gonna do the same thing as before, right? Except that, right, maybe let's not jump straight into it, but let's see what we achieve by running it frame by frame. Well, we get a lot of output, a lot of output. And this happens because for each frame we output the whole line. There is no new line, and we proceed outputting the same line again and again. And this is where one of those ANSI escape codes comes into play. As you can see, there is a command to save cursor position and restore cursor position. Let's try to use that. So before we start outputting our line, let's save our cursor position. So try writer print. So it's going to be x1p command, and S stands for save. So this is pretty much it, right? In Zig's param, we store our current cursor position. And once we have printed everything, we can, maybe even before printing each new line, we can restore the position of our cursor. To restore, we need to use U. Let's see how that works. And we pretty much get the same result as without animate flag, which is like good, but we want something different. First of all, we are printing every single frame at the highest speed possible, but we want to make small pauses between each line print, or each, like for the same line whenever we print it, and then like restore the cursor. We want to do some napping time. How can we achieve that? Let's see. I do not remember. Let's try to figure out. Maybe like process sleep. No. Let's see. Zig sleep time sleep, right? So Zig stdin time sleep, and it says nanoseconds. So that's like 1 divided by, let's say 30. Let's see what it does. So we make a small sleep after printing out the line in it every frame. Seems to be good enough pause for now, But the thing is that every frame, when we print out the line, it stays, or it gets printed with the same colors. And we need to adjust it somehow. And we pretty much already have frame counter, which is frame. So we can adjust the offset by saying, hey, float from int, which is like frame times 3, something like that. Okay, can do it in one go. Lines per frame. No, just plus frame, because the multiplication happens inside get rainbow color. Let's run it, and you can see that we have the animation, which looks kind of the same as lolcat's ones, which is pretty damn great. Now, I believe this is about it. I have covered everything I wanted. Although no, let's stop right here. One thing I noticed is that when we run lolcat and then we run our command, you can see my cursor is blinking, or it stays at the end of the line, while lolcat has absolutely no cursor at all. And we can achieve the same result by, I think it was mentioned in this article here, nice escape codes, where we can hide the cursor, right? So let me show you again. If I run our program, you can see right here, the cursor stays here, right? And if we run lolcat, there is no cursor, so it's hidden. So let's do this small adjustment on our side as well. Pair of escape codes, so this probably hides it, I hope, because it says show and hide. So show and hide, so this hides it. We can hide it where do we hide it? If it's animate, let's hide it. Right, we can pretty much print it here. So we hide it, we save its position, and once we're done, we can then show it again. I think we should maybe do it outside of the while true. Yeah, let's do it like this. Writer print something. So it was x1b question mark 25l to hide it, and at the end, the while loop, it's going to be 25h to show it. Hopefully I didn't mess it up. We run our program and voila, there is no cursor, and in the end it is shown. Now, I believe that this is pretty much it. I will leave links to these ANSI escape sequences, the blog post, in my companion blog. You will find the link to that in the description. I hope you enjoyed it. If you like this content and would like to see more, I appreciate if you give this video a like and subscribe to my channel. Bye!